All right, let's do topic 2. So we're gonna start doing the math, and I just have to let you know, topics 2 and 3 are the most important topics for the course. Okay, so we're learning the math, and then later in the course, we're gonna apply the math into different settings. Okay, so unless you know the math, you can't do the problems later on. Okay, so you have to know topics 2 and 3. And usually the people who fail the course, when I speak to them at the end of the semester, usually they just never got the math. Okay, so these problems are very important, and yeah, make sure you work on topics 2 and 3. So we're doing the time value of money. Okay, so this is the basic question we usually ask when we cover time value of money. So what do you prefer? Okay, so think about the two options. You could get $1,000 now, or you could get $1,000 in year one. Okay, so usually in in-person lectures, I get a bunch of answers, all good answers. Some people just prefer getting the money right now, which is reasonable, and some people talk about inflation, saying that usually $1,000 right now is going to be worth more than $1,000 later because of inflation. That's true, but sometimes you go through periods of deflation too. Okay, so it's not always true, although they're all good answers. Okay, well, the answer here, which one do you prefer, should be, the first one is better, but why matters more. Okay, so option 1 is preferred because you can invest the $1,000 right now at something called a risk-free security. Okay, so you can invest at a risk-free rate and get a larger amount in year one. Okay, so you're putting in the $1,000 in something called a risk-free security. Okay, so we'll talk about this soon. Okay, so the key idea behind the time value of money concept is that the money that's available right now is worth more than the same amount of money in the future. Okay, but to me this is too simple. You really got to understand the math. Okay, so let's do this real quick. Time value of money. Okay, so yeah, the options are, first you can get $1,000 now, and we're comparing that against the second option of getting $1,000 in 1 year. Okay, so we're gonna come up with an objective way to evaluate which one is better. Okay, and to do that, we'll first talk about something called the risk-free security. Risk-free security. Okay, so this thing is a theoretical concept. So we're gonna assume that there exists a security that is completely risk-free. Okay, a security that is completely risk-free. So risk-free here means there's a 0% chance, I'll just use the number. There's a 0% chance of default. Okay, so whoever is making this promise, they will never fail to fulfill their promise. Okay, there's a 0% chance. In other words, you'll get your promised payment for sure. You're promised, I'll just say promised cash flow for sure, no matter what happens. Okay, 0% chance of default. Okay, so again, this is a theoretical concept. Okay, so let's say there exists a risk-free security that guarantees a risk-free rate of return of 5%. Okay, so this notation just means the return that you get by putting in your money in something that is risk-free is 5%. Okay, just R, just the rate of return. Okay, so now we can compare the two options using this concept. Okay, so first option, I'm gonna draw the timeline for this option. So we're gonna get used to drawing timelines. Okay, so we're just indicating the time periods. Right now is always time 0, and we'll say 1 year later from now is time 1. Okay, so what option 1 promises you is you'll get $1,000 right now. Okay, so you want to put the $1,000 above time 0, indicating when the cash flow is occurring. Okay, and option 2 is promising something else. We still have time 0 and time 1, but the promise is that you'll get $1,000 in year 1. Okay, so these are two different promises, but using the risk-free security concept, we can say, well, first, it's tricky, when you're trying to decide which one is better, because the cash flows are occurring in different time periods. Even though we're dealing with the same amount, one is occurring right now. The second option, it happens in year 1. Okay, so the goal here is we're going to try to align the time periods by using this risk-free rate. Oops. Okay, oops. Oh, okay. Let me just do that. Yeah, so if you were to invest this amount in a risk-free security for 1 year, we said the risk-free rate is 5%, right? So this $1,000 grows at a 5% rate for 1 year. Okay, so if you can do the math, $1,000 times 1.05 would equal 1050 in year 1. Okay, just real quick. Here we're actually applying the little formula that we saw in the previous video. If you recall, PV was equal to future value over 1 plus R to the nth power, right? In the determinants of stock price slide. Okay, so if we do a little bit of algebra, we can move this entire denominator, is that denominator? Yeah, denominator to this side, getting future value by itself. Okay, so future value is then equal to PV times 1 plus R to the n. Okay, here the little in option 1, the PV is the $1,000 that occurred in year 0, and the risk-free rate is the R, 1.05, and the n is 1, because we're trying to convert it into time $1. Okay, so the future value can then be calculated as 1050. Okay, yeah, a little side note. Okay, but yeah, so what this is saying is, since you get a guaranteed return of 5% if you put your money in a risk-free security, getting $1,000 right now is essentially equal to getting 1050 in year 1. Okay, so getting $1,000 now is equal to, because it's guaranteed, risk-free security. Okay, equivalent to getting 1050 in year one. Okay, yeah. So now we can just focus on this part. We can focus on this part and this part to make an objective decision. Okay, so here, based on these numbers, now it's really clear, right? So now the choice between option 1 and option 2 becomes getting 1050 in year 1 versus getting $1,000 in year 1. Okay, again, notice that we've aligned the time period, okay, in year 1 and in year 1. Okay, now we can just look at the magnitude and say, oh, 1050 is, clearly better than $1,000. So we can say option 1 is objectively better. Okay, doesn't even depend on your preference, it's just a greater amount, so it's better. Okay, so yeah, this is the time value of money. Okay, so this example was easy, but suppose that I gave you this example. First option is you get $1,000 now, and second option is you get 1030 in 1 year. Okay, now it's a little bit tricky. Okay, so without this risk-free rate, one cannot, you can't just look at this and say, which one is clearly better. Okay, you need to know the risk-free rate to make an assessment. Okay, yeah. So that's what we're doing. That's the time value of money. Okay. Yeah, so to illustrate this a little bit more clearly, I'll just give you other examples. You can think of the time value of money as a unit conversion tool. Okay, time value of money as a unit conversion tool. One way to think about this. Okay, so to give you an example, we convert units all the time. Okay, for example, if we're talking about weight, in the, what do they call it, in the imperial system, the US and the UK, everything's measured in pounds, right? Or I mean, the weight is measured in pounds. In using the metric system, I think it's called the metric system. Rest of the world uses kilograms. Okay, so suppose that someone's weight is 100 kilograms. Okay, we'll say this guy weighs 100 kilograms. Okay, we can display the same weight in pounds. Okay, so the pounds, 100 kilograms is approximately equal to 220 pounds. Okay, and the conversion factor is about 2.2. Okay, so here, whether we say this person weighs 100 kilograms or 220 pounds, we're like referring to the same thing. The weight doesn't change. We've just expressed the weight in different units, right? And there exists some kind of a conversion rate. Okay, I'll just say conversion rate. Yeah. Same thing applies to length. Okay, suppose that we're trying to measure something that's this long. Okay, probably a little off scale, but I will say it's 1 inch in the US. For the rest of the world, we multiply this by about 2.54. I'll use the same color. We multiply by 2.54 to express the same length in centimeters. Okay, here too, we're referring to the same thing, how long this thing is, but we've just expressed it in different units. Okay, and I'm in Korea right now. Temperature is also different, right? Goes from Fahrenheit to Celsius, but how hot or how cold the temperature is, we're measuring the same thing, expressing it in different units. Okay, so we're doing the same thing in this course, but instead of talking about these other things like weight, length, temperature, we're talking about value. Okay, value of a security, value of a deal, or whatever we're trying to measure. Okay, so the value of this deal, we'll just call it this deal. Using the example that we just used, option 1, value of deal 1, it can be expressed in times $0. Okay, that is $1,000, but this dollar is in time $0. Okay, right now what we did up here, right here, is we've expressed the same deal into a different unit, in a different unit. So this was expressed in time $1. Okay, as I said before, we were trying to align the time periods so we could make a comparison with the second option. Okay, because the cash flow for that one occurred in year 1. Okay, so we're making the unit conversion, but this conversion factor depends on the R. So it's a function of R and N. Okay, so discount rate. So you don't have to know this notation, but the factor depends on the R and the N. Okay, remember we did 1.05 to the first power, right? So this was R and this was N. Okay, so that's all we're doing. Okay, so we're gonna use the same time value of money concept for all the problems that we're gonna do. Okay, but the problems get complicated, so we deal with multiple cash flows, and people get all confused, but we're doing the same thing. So when the cash flows become more complicated, people just forget everything, but we're applying the same concept, time value of money. Okay, we're gonna express all these numbers into like time $0 usually. Okay, so that's all we're doing. Okay, time value of money. Okay, oh yeah, and before we move on, one more thing. We talked about this concept called the risk-free security. Okay, risk-free security, right? And I said it's a theoretical concept, and it's a security that's completely risk-free. So in the real world, nothing is really risk-free. Okay, no one can promise you something and guarantee that promise, right? But the closest thing to a risk-free security in the real world is, this might be on the exam. It's usually on the exam. Okay, the closest thing to a risk-free security is the U.S. government bond. So we'll talk about bonds later in the bonds chapter in exam 2, but this is basically the U.S. government borrowing money from investors. And they're saying, if you give us like $950 right now, we'll give you $1,000 in 1 year. That's their promise. Okay, but historically, U.S. government has never defaulted on their promise. Okay, never defaulted. So yeah, so in the real world, people will use a 10-year U.S. government bond yield, bonds yield, as the risk-free rate. Okay, but just know that for the first exam, the U.S. government bond is often considered a risk-free security because historically it's never defaulted, and theoretically it can just print money and pay the investors back. So it's a little bit tricky, but yeah, that's it. Okay, but yeah, suppose that the world ends in like 1 week. Okay, this promise cannot be fulfilled. Okay, so nothing in real life is risk free, and maybe there will be like a third world war. Who knows? Okay, but for now, we're gonna say this is the risk free security in the real world. Okay. Okay, that's that. Yeah. So time value of money, as I briefly showed you earlier, we're gonna use this for the rest of the course. Okay. So comparing different investment opportunities is tricky. It's because the different securities come with different details. Okay. So the amounts of cash flows are different. The timing of the cash flows are different, and the risk associated with the cash flows are different. Who's promising the payment, right? We talked about the U.S. government and the Iranian government in the previous lecture, right? So, to give an example, suppose that investment one promises these cash flows. It's just a strange, random stream of cash flows. I just made it up. Now, investment two promises these cash flows. Okay. So as you can see, now things got a little bit more complicated than the $1,000 now versus $1,000 in year one example. But this is more realistic in real life. Yeah, probably not this messy, but it's complicated. Okay. So time value of money allows us to come up with one number for each of these investments, so we can compare the investments objectively. Okay, so what we're gonna do is basically, real quick, for investment two, I will convert this cash flow into time $0. Okay, so it'll be a little bit smaller. Maybe the present value of that will be $290. Okay, I'm gonna convert this cash flow to times $0, so that'll be maybe 190. Okay, and I'm gonna convert this, and this. Okay, and I'll add them up to get the net present value of investment two. Okay, I'll come up with the single value for investment two, compare that against the net present value of investment one, and then whichever one is greater is a better deal. Okay, that's how we're gonna do things in this course. Okay, yeah, some terminology we have. You saw the formula before. This formula, you're gonna see it again real soon. But future value is just the value of an asset at some future time. Okay, so any cash flow that occurs in the future we'll just call future value. Okay? So let's say if there's something here, we'll just call this future value. Okay, present value is a value of an asset right now, so it's usually in time zero, but it doesn't have to be in time zero. Okay, so if we called this the future value, I'll use a different color. We can say we want to convert this into time $2 just for fun. We can call this present value as of year two. Okay, well, so we'll just say future value is some later cash flow. Present value is some earlier cash flow. Okay, yeah. And the net present value I just mentioned, it's the sum of the present values of all future cash flows. Okay, so going back to this example, if we convert all these numbers into times $0 and we add them up, that'll be the net present value of investment 1. Okay. Yeah. Compounding is the process by which an asset's earnings is reinvested to generate additional earnings over time. Okay, so that sounds a little complicated, but we're just saying whenever you get interest payments, you will reinvest that interest payment in the same security, so it generates more earnings as time goes on. Okay, that's just compounding. Okay, but looking at this from a timeline perspective, whenever we go from here to, say, time 4, we just call this, we're compounding this cash flow by 4 years. So going forward in time is usually compounding, and discounting is coming backwards in time. So if we start from future value, we want to convert it to time 0, we're discounting this cash flow by 4 periods. Okay, so it's basically undoing the effect of compounding. Okay, yeah, so just some terminology. Okay, so yeah, so yeah, you probably know this. Usually students know the difference between simple interest and compound interest, so we're going to go through this quickly. So under a simple interest scheme, interest is earned only on the principal amount. Okay, simple interest only on the principal amount or the initial investment. Under compound interest scheme, interest is earned on the principal amount and on previously earned interest. Okay, so in this course we're going to assume compound interest for all the problems. Okay, but let me just give you an example. Suppose that you put in $100 in something that generates 5% return per year. So under a simple interest scheme, yeah, it looks like this. You put in $100, okay? So in year 1, you generate a 5% return. That is, from that $100, you only get 5%, earning interest on the principal only, okay? And the ending balance is 105. In year 2, your beginning balance is 105, but you're still only earning interest on the initial amount. So you earn 5%, which is $5, and the ending balance is 110. In year 3, same thing. Even though the beginning balance is growing, you're still only going to earn interest on the original amount, $100. So you get $5, okay? And this continues forever. Under compound interest, it's a little bit more tricky. In year 1, it's the same thing because you're beginning with $100, you get $5 on the principal amount. Okay, so the ending balance is 105. But in year 2, you start earning more interest. So you'll get the $5 from the initial principal amount, but you also earn interest on the previously earned interest. So 5 times 0.05 is 25 cents. So you're earning additional interest on previously earned interest. Okay? So the ending balance is now a little bit greater. And in year 3, now you've accumulated 15 or 10.25 in interest so far. So you're going to earn more interest on the previously earned interest, but you're still earning $5 on your principal. Okay, so as you can see, the amount will grow as time goes on under compound interest more quickly compared to simple interest. Okay, So here we're assuming compound interest for the remainder of the course. Yeah, power of compounding, just for fun. I think I might be wrong. I think either Einstein or someone smart said this was one of the, I don't even know, one of the N wonders of the world. Okay, someone smart, I'm not, yeah, someone smart said something, nth wonder of the world. Okay, yeah, yeah, power of compounding. Maybe it was Einstein or someone else. Suppose you have $100 that you want to invest in a savings account that earns 5% interest, compounded annually. This is the key. How much will you have at the end of 1 year, 5 years, 10 years, and 30 years? Okay. So if you do the math, so this is the formula that I showed you earlier. That's the future value equals PV times 1 plus R to the N formula. If you use that, you'll see that after year 1, 105, after 5 years, 127, after 30 years, your money more than quadruples, and you get 432. Okay? So this illustrates the power of compounding. After year 1, you only got like 5% return, but after many years, your return just snowballs. Okay? So that's why people say you should start investing early, however small the amount is. Okay? Yeah. Okay. Again, timelines. You want to draw your timelines. So, yeah, I don't know what it is, but previous semesters here and at my previous schools, some students just don't draw timelines, and they're usually the ones that fail the exams and the course. Okay, so you want to draw your timelines. Okay, yeah, I mean it's just the best way to understand how to do the problems. Yeah, if you don't follow the instructions, I can't help you at all. Okay, yeah, but once you get it, you don't have to draw it. But a lot of people just don't get it and they don't draw it for some reason. Okay, it's just a graphical illustration of the timing, the magnitude of the cash flows, whether it's an inflow or the outflow. Okay, for example, if you have a $300 income in year 3, we just look at year 3 and put $300 on top of year 3. Okay, yeah. So yeah, as I talked about earlier, later on the cash flows get a lot more complicated, and the formulas that I'm going to show you work a certain way. Okay, so drawing timelines will be helpful. Okay, that's why I recommend it. Okay, so here are the equations. You've already seen these equations. PV is equal to future value over 1 plus R to the N. So you want to find, when you're given some future cash flow, the R and the N, you can find an earlier value. Usually we're going to try to find present value as of time 0. Okay, that's the subscript that I'm going to use. Usually if I say PV times 0, I'm just saying it's the value of something as of time 0. This subscript, you don't put it in your calculator. It's just a time indicator. Okay? And when I say things like future value in year 10, also, you don't put this 10 in the calculator. I'm just putting it there so that we don't lose track of the time. Okay? Okay. Yeah. And this is the new formula that I just showed you. Future value is equal to PV times 1 plus R to the nth power. Okay? The R, again, represents risk, but it's also called the interest rate or the discount rate or the rate of return. Okay? It's a little bit tricky, but these are the different names. Okay, N represents the number of compounding periods, or when the cash flows occur. Okay, yeah. So as I talked about the math problems, I already uploaded the videos last semester. I recorded the videos and they're already there, so you can refer to those. We're gonna, for the exam, you have to know example 1, example 2, example 3, and example 4. Okay, so these 4 examples use these 2 equations. Okay, so you want to practice using these. Okay, but the key here is understanding the context. Okay, so your first job is to transfer these words and make it into a math problem. Okay, so you can refer to the solutions. Okay, yeah, so NPV, I'm just going to cover the concepts in this video. NPV, as I talked about, is just the net present value given multiple cash flows. Okay, here, so if investment promises these cash flows at time 0, cash flow at time 2, cash flow at time 8. If you were to calculate the NPV as of time 0, you want to calculate these individually. Okay, so we'll talk about different cash flow patterns in topic 3, but for now, this doesn't fit into any pattern. Okay, so PV as of time 0, for the blue cash flow, it's already in time $0, right? So there's no conversion necessary. But for cash flow 2, this one occurs in time 2, so you want to discount it back to time 0, discount it back twice. And that's why N is 2 here. Okay. For cash flow 8, this occurs in time 8, and we want to convert it into time $0. So we're going to apply the same PV formula, but now the N is 8 because we got to go back 8 years. Okay. So now to get the NPV, we have to sum everything up. Cash flow 0 and PV of cash flow 2, PV of cash flow 8. And we're adding everything up. Okay? So more equations. Okay? So we're still dealing with the same set of equations. Notice that we started with this, right? Future value 1 plus r to the n. Okay? Here, we're just solving for these other components, r and n, given the other 3 components. Okay? So if you solve for r, if you do a little bit of algebra, r is equal to future value over PV raised to the 1 over nth power minus 1. Okay? Here, again, these n's and zeros, they're time indicators. So you don't actually put anything into your calculator. Just keep track of what time period you're dealing with. Okay, so it could be future value in year 10, future value in year 5. It depends on the problem. Okay, but you don't do anything with this in your calculator. Okay, and make sure you know how to use your calculator. Okay. I probably mentioned this in the introduction video, but it doesn't matter which calculator you use, but for the exam, you just can't use your phone because, you can't use your phone, and you can't use Excel. Okay, so usually people use a scientific calculator or graphing calculator. Some people use a financial calculator. Doesn't matter what you use, but you have to figure out your own calculator. Okay, so these days you can just ask AI, how do I use this calculator? Give it the model number of your calculator, and give it the problem that you're solving, and you just got to figure stuff out on your own, these things. Okay, figure out your calculator. Okay, yeah, so in any problem, if you're given the future value, the present value, and the n, you can figure out the r, okay, the annual rate of return, or the interest rate, or the discount rate. Okay, this one, if you know the future value, PV, and the r, you can figure out the n. Okay, so you'll see in example 6, you're gonna figure out the r given the future value, present value, and from these numbers you can figure out the number of years. Okay, so PV, future value, and n are given, and you're trying to figure out the r, and you'll do that using the r formula. And in example 8 here, you're given the r, you'll see in the problem later, you're given the current value, PV, and you're given the future value, the target. And we're trying to figure out how long it would take. Okay, so you're trying to figure out the n. That's when you're going to use the n formula that's shown here. Okay, so this n formula is a little bit tricky. We have the natural log, so your calculator should have a button there where you can do the natural log. But if you use the log button, you get the same answer. Okay, so you can try both ways. They'll both give you the n. Okay, yeah. So yeah, for the exam, you have to know. I talked about this earlier, right? Whoops, what is this? Yeah, example 4, 1, 2, 3, 4, and then where did example 5 go? No example 5. Example 6, 7, and 8. Okay, we're gonna skip example 9 and the rule of 72. Pretty useless rule. I should remove it. Yeah, and example 10, not on the exam. Okay, so anything we don't cover in the course will never be on the exam. Okay. Yeah, this we talked about in the determinants of stock price. Price slide before. Remember, I gave you, yeah, we did this example, but yeah, this is not as important. Okay, yeah, good.